Morning, everyone. Time to get started. Welcome back after lab days. I expect that for many of you it will feel at the moment that all you're doing is coding and there's a ton of new methods coming at you and where is all this going? Here's where all this is going. We're trying to give you some skills so that in a few days we can actually start doing some interesting data analysis. Randomize, take random samples, explore, and so on. And for that you need some basic working knowledge of the system so that you can answer interesting questions. So that's where we are right now, and I think possibly part of next week will have that same flavor again. After that, we come into the inference. Because after that, you'll have the techniques to take random samples, look at what the probabilities look like, and so on, all without a lot more overhead of coding. So if you're feeling that is a little coding heavy right now, it's that way we're kind of front-loading the coding so that we can do interesting things quickly. Right, so as always, my first slide doesn't work. Okay, here we go. Announcements. So it's all about enrollment today. I've got a meeting this afternoon. I'm going to try and sort out the enrollments, and there are 30-something students still on the waiting list for the class. I'm going to go through one by one and send everybody an email. Either, we can get you in, or I might have to ask, can you make a different lab time? Or I might have to say, I'm sorry, this is going to be full. And I'm going to try my hardest to do the maximum possible. I don't need to have empty seats. However, there are limits, and the size of the room is one of them. And so we're going to do our best. Hold your horses today. These past couple of days, I've had many, many emails from students from other classes who are discovering that maybe they would prefer to be here. There's a lot of people in this room. Put yourself on the waiting list if you can. I will try for everybody, but at this point also some coding knowledge does help. So I will try for everybody, but I am not certain. Everybody who's on the waiting list will hear from me sometime this weekend. Concurrent enrollment, I apologize, but this class is going to be full with registered students, so I can't do anything about that. Auditors. As you know, data8.org is a public website. That's where everything is. The textbook is public. You can find it on that website. The lectures are available there. If you have a berkeley.edu email address, we don't have the resources to, transform our other materials like homeworks and labs and so on to a form in which we are happy to give it out to the general public at the moment. So you're welcome to follow the class along, but other materials are going to be for the students who are in the class. In response to numerous questions about I joined late, I couldn't turn in this, what's going to happen to my credit, and so on, just please do current work. We're going to look at when you joined, and we're going to prorate things accordingly. It'll be fine. And one or two homeworks here and there rarely make a difference, as do one or two labs. So don't worry about it. Just keep doing current work. You will need to go back over old stuff to be able to do current work. Do it for that reason. One other thing about communication, I'm getting a lot of emails with, Professor, I couldn't submit my homework. Here's a PDF. Can you grade it anyway? That kind of thing. I don't do that, because I really can't for 500 students. Please, 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 that kind of query sent to your GSI. Because otherwise I have to go find who is the student, who is their GSI, and then forward. It's much faster if you email directly. If you have some kind of technical problem, and you can find all the GSI contact info. If you go to data8.org, and there is a tab on top that says staff contact, you can find us all. Right? Is that clear? Does it seem reasonable? All right, we're trying to do the best we can with big numbers, and in the end, it does work out beautifully. I realize that right now it's a tense time for people, and I'm sorry about that. It will settle down. Does anybody here have administrative questions that I can take? Yes?
When's the deadline to add connectors?
When is the deadline to add connectors? I do not know. Please ask connectors. Sorry. They may have different ones. Okay. What I'd like to do is get going with a little recap of last time's work. And last time we were working on rows of tables, and we figured out how to rearrange rows in increasing or decreasing order of one of the columns. We figured out how to create a table that had a specified set of rows, and we figured out how to create a table that had rows that specified a condition, so that Python had to go in each row, see, does it specify the condition? If it does, put it in the table, otherwise not. And the methods were respectively sort, take, and where. And what I'd like to do to get a start is to make sure that we're all speaking the same language. So we've got a table. It's got columns. And write one line of code that evaluates each of three things. I'm sorry, I drink unconscionable amounts of bubble tea, so it's going to pop up a lot. Yeah, I made up that flavor. It's the one I don't want. Okay, so there are three things there, three quantities there that I would like you to calculate based on the information given. Please make a noise, talk to your friends, and work out something that works. All right, let's see if we have progress on the first one. What is the first question you should be asking yourself? What's it returning? Thank you. Excellent. And what's it supposed to return? A table, right? So what's a decent method to use, you think? Where sounds like a great method. Where returns a table. Yep. And where returns a table with just the rows that satisfy a certain condition. And now you are down to what is the syntax of where, so that I can pick off just these rows. And where takes how many arguments? 2 arguments. What's the first argument? Thank you. The column that you look at to assess whether the row satisfies the condition or not. In this case, which is it? Flavor. Thank you. And so then there's the question of, do you remember the syntax for how to say not garlic? Yep. And we went through that last time. I'm just going to show it to you because based on the conducting that I did last time, I think you guys are pretty good at this. What do you reckon? It'll work? So you told me that I should take I should use the method where. This is how you apply the method where to your table. First argument is the name of the column, and this is how you say are not equal to. Now I have a question for you. Could I have used are not containing garlic? Could I have done that? Well, I could have. I wouldn't have got an error message. Yes? Would I have got what I wanted? Are not containing garlic. You know what else it would have left out? It would have left out the garlic onion flavored bubble tea. Yes? And who knows, maybe I'll love that. Right? The point is, this is really specific, does not include that flavor. Okay, so just a little bit of care is helpful. Now, when you write your own code, sometimes you may get, issues that appear to be picky, but, the question is rather clear, and so we stick with that. Okay, next one. A flavor that has the lowest of all prices. Okay, so what in the end are you going to want to do? You look at what you want in the end. What do you want in the end? Do you want a table? No, you do not. You want a number, right? What's the one way that you have at the moment to get a number? Item. That's what you have. Everything else returns a table or an array. You got item. Who's got an item? Okay. You guys are way too young to have read Herb Caen, but never mind. Herb Caen, C-A-E-N. Look him up. Okay. C-A-E-N. Not right now, but please look him up. All right, so you need an item, and therefore you need an array. What gives you an array? Column gives you an array. All right, so you need to use column on something. And now you need the lowest, and therefore you need to do what? You need to do sort. You're in business. Okay, so all you need to do now is put those things together sort of in backwards order. All right, so step one, we're going to do what to our table? Sort, how? By price, yes? Now there are two things you can do. You can either sort just as is, or you can sort in decreasing order. I've done it one way, you might have done it a different way. Either way, you have to then extract the column and then take the appropriate item. Yep? All right, so if we sort just without any specifying decreasing, then it will sort from lowest to highest. Do you agree? That's the default behavior? So in that case, which item do you want to pick off? Okay? Now, note that I've said there are other correct answers too. In this case, there is certainly another correct answer, which is a little more long-winded but possible. You can sort descending equals true and then pick off the last one. Yeah, you could do that. In all cases, this column flavor can be referred to by its index. What's the index of that column? How can you tell? Because it says in that order. All right, so flavor is column 0. Wherever you see flavor, you could just type in 0. That makes your code harder to read 1 week later, because you don't actually know what it is, but you could. Okay, and the last one, table consisting of rows 3, 7, 11, ... How far is it going to go? 3, 7, 11, 15. Okay, so, There's a little issue with the 19, isn't there? Yes, what are the row indices? What's the first row index? 0, 1, 2, 3, up to 18. Okay, so then indices are an issue. And I'm going to tell you what I did. What's the method we're going to use? I just stuck in 27 at the end. I don't care. Right? It's going to figure out what it needs to do. It's going to go 3, 7, 11, and it's going to stop when it stops. Okay? So if you are picking off ranges like this and you don't want to fuss about the endpoint, just use some very large number and you'll be fine. All right. What I'd like to do now is get on to... So good. The syntax, I think, is getting small. Yes? Which problem, please? Oh, I see. The question is, could we use dot in part A? Could we have used drop? Yes, drop drops columns. We're talking about rows. All right, we want to move. I'm very happy to see how you are coding. I am going to start today by looking at pictures. You saw last time, by the end of the lecture, we were looking at screens full of numbers. And we were scrolling and so on, and that just becomes a mess. And so today we are going to spend our time drawing lots of pictures. The pictures themselves are going to be very simple, so is the code to draw them, but I hope you'll see that even with very simple pictures, there are interesting questions of interpretation. Okay, so here goes. This is my reminder of what the file names are. So it's Friday, we're going to the movies. All right, so this is a table that we get from IMDb, which is or actually offshoots of the IMDb. This is the International Movie Database, who very kindly make tons of data publicly available. And what these data are, each row corresponds to an actor. An actor can be female too. Do we have in the first 10 anybody? Yes, Scarlett Johansson, there we go. Okay, so, what is being measured is this column, the total gross, is the total amount of box office receipts of movies in which this actor had a part. It's not the amount of money that the actor makes. You take the actor Harrison Ford, you list all the movies that Harrison Ford has been in, you total up the domestic US-Canada box office receipts, and that's the number. Everyone clear? It's in millions of dollars. That's a lot of money there. Okay, so Harrison Ford, according to this data set, has been in 41 movies. I'm going to point out that they are not counting cameo roles, right? Not where they just show up or say one line in the background and so on. Okay, this average per movie, obviously each of the 41 movies doesn't make the same amount of money. What they've done is say, okay, fine, but we won't look at all that variability. For now, we're just going to take this total amount of money that the movies made and divide by 41. So split that total amount evenly over all of the movies that this person made. And this number one movie is, of that person's movies, which is the one that had the highest box office receipt? Right, again in millions of dollars. Okay, so questions about what the columns contain. Anybody? And so what has been picked off, yes? That nothing is, to my knowledge, adjusted for inflation. I'll talk about that by the end of today's lecture. Thank you. What this data set contains, and we just picked it off a site to which we have a link in the textbook, is the top 50 actors by this total gross. So Harrison Ford's right up there, Samuel Jackson, and so on and so forth. And do you want to look at all 50? There are lots of names on that list that are familiar to us. Okay, so what I'd like to do now is I would like to visualize some of this information. Even with only 50 rows, there's a lot of stuff going on here. And what I would like to do is I would like to look at the relation between the number of movies and actors in and other variables. Okay. And the first thing we're going to do is we're going to look at the relation between the number of movies and the total gross. And the way we're going to do it is we're going to draw what is called a scatter plot. This is the thing that you saw in my very first lecture when we were looking at the number of characters in a chapter versus the number of periods. You remember that? It's a plot that has a point for every actor, and on one axis you plot one of the variables, and on the other axis you plot the other one. Not surprisingly, the method is called... actually, I should look at the column names. Number of movies, uppercases matter, total gross. Okay. So actors is the table. The method is called scatter. And the arguments are the variable on the horizontal axis, followed by the variable on the vertical. And you get a picture that looks like that. How many points are there? 50. There's one for every actor. And each point on the horizontal axis, you've got number of movies, and on the vertical, you've got total gross. And I want to take just a rough look at that. That graph is more or less a cloud of points that is more or less going up. You agree? And so that's somehow signifying there's some kind of relation there. Something's happening. We're not saying what yet. But there is some kind of relation that is going up, means that in general, the actors with the higher number of movies tend to have the higher total gross. Is that a surprise? Surely not. You're adding more money from more movies. Okay? So in general, not always, of course. Here is somebody with a pretty middling number of movies with a very high and gross receipts. But in general, right? So the term that I've just that we use for this is positive association. High values of one tend to go with high values of the other. Equivalently, low values of one tend to go with low values of the other. So we're seeing positive association, no big surprise here. What I would like to do now is change the variable. Actually, before I do that, any question about the code? It's clear what it's doing? All right. And I'm hoping that I'm remembering the name of this variable correctly. So we're going to look at the number of movies versus the average receipt per movie. And that looks quite different. This is now negative association. That's just popping out at you. Agree? The more the number of movies, the lower the average gross. And one very interesting thing is this person here. And why don't we start by looking at this person here? Okay. So how do I find that person? Lots of ways, but any suggestion? I could sort. That's one suggestion. That would work. Anything else I could do? Because you're looking at a plot that has numbers on it, so you have other options as well. You can do where and say where the number of movies is greater than 70. Sure. You could do that as well. Yeah. So you could do various things. Why don't we try that second one? I think it's a little shorter. R above. Yeah, sure. How about 75? Robert De Niro. Robert De Niro. And look what he's remembered for if you just count money. He is remembered for the masterpiece. Yes. Okay, so one of the things you're noting is the position on average per movie is not a reflection on the quality of the actor. Right? And so now if you think about people who make lots of movies, you understand that some of them will make big blockbusters. Some of those movies will be blockbusters, but they may do other genres as well. They may do very small things. They may do art house things. They may make some that are just duds. Right? And so the more movies an actor makes, the more variability there is. Right? And in general, that's going to pull down an average if you just look at box office receipts. And, you can go through these data in your textbook. You can go through, and just around him is, Samuel Jackson, Liam Neeson. These are very fine actors. They do a lot of movies. Some of them make money, some of them don't. But they're very fine actors. So the negative association that we're seeing what we're doing is we're looking for other variables that may influence it. Those kind of lurking variables that we talked about in our very first couple of lectures. Another interesting one is this. Any guesses? I mean, that's off scale. No? That's fine. You okay? Shh. Yes, quietly.
Jennifer Lawrence.
No.
Oh.
It's not Jennifer Lawrence. Okay. We're going to find that person, okay? Using the same R below, what, 10? Right? So very small number of movies. So this, okay, here we go. Anthony Daniels. Anthony Daniels is the king of the average per movie. Anthony Daniels. Come on, everybody knows Anthony Daniels. How can you not know Anthony Daniels? Anthony Daniels rules. Here is Anthony Daniels for your viewing pleasure. He has made 7 movies. Each time he has played the same character. All those 7 movies have been blockbuster. If you take averages, he rules. So, when you are comparing averages across individuals, please take a look at what the data actually mean. All right? Now, actually, I think he's a very fine actor. It's not easy to do what he's doing inside that suit. He does not have, as yet, the stature of Robert De Niro. However, he does a fine job, and both of them do wonderful jobs in their own ways, and they're at vastly different ends of the spectrum for reasons that we've just examined. So the point I'm trying to make is the coding here was, I got to take this guy off because nobody can listen to me here. Thank you. The code is rather easy, all right? And the pictures are rather simple. But even with simple pictures, it's a good idea to look hard at what's going on. All right, there's another kind of simple picture that you have seen a lot. That's just a line graph, right? And that's usually used to see how something changes over time. Very frequent use. And so what we're going to do is, on sticking with our movies theme, we're going to read in a different table of movie data. And what this is there is one line per year. And in each year, there is the total gross of all U.S. movies released. Again, in millions of dollars. Everything, all of them. The number of movies released that year. And the number one movie that year. Questions about the variables? So now we're going 1 year at a time. So for last year, they just added up every single new movie that was released that year, all the money that made in U.S. and Canada. And then, how many movies and so on. And so what we're going to do is, I actually would rather not look at absolutely everything here, so I am going to select, and I was really bad on the movie theme. I can't resist this. We're going to look at the 21st century. Sorry for the pun. Just the 21st century, and what I'd like to do is I would like to see how the number of movies has changed over the years. Okay? And so for that, the method is called plot, and it takes exactly the same arguments as scatter. First, the variable on the horizontal axis, which I will use year for that, and then we're going to plot number of movies. Sorry, this is movies. No, wrong variable, wrong table. This is my new one. I have drawn the other one in your textbook, but today I just want to look at this. From 2000 to 2015, the number of movies per year looks like that. Do you see a dip? Where's that dip? After the financial crisis of 2008. In 2009, the number of movies released went down. Okay, no surprise there. Hollywood was tightening its belts. Everyone was tightening their belts. Okay. What is interesting is what happens if you look at the amount of money made. So the other variable. So now we're doing same years, amount of money made each year. Look at 2009. Did the studios suffer? Not really. Not really. Small number of movies, but money is fine. And there is a real lesson here, and I've linked you to some articles and so on in the textbook. When times are tough, Americans go to the movies. Yeah, because if you were going to take holidays or something or go to expensive restaurants, you can't afford that anymore. The movie is an easy way of giving the family an evening out, right? And apparently there are studies that show that people want to go out where there are other people and they want to forget their troubles. And so the movie business does well after a recession. And that's partly what you're seeing here. The other thing you're seeing here is Avatar. Avatar just knocked the box office for a loop. And so while we're on that subject, soon we're going to look at the top movies overall ever, but Avatar was one of them, and it had one of the Harry Potter movies and one of the Twilight movies all came out in 2009, and so everybody went to the movies to forget that nobody had any money anymore. So line plot, easy to draw. Again, interpretations are interesting. So what I want to point out now is something a little bit technical. You look at the variables, and both variables are numerical. Yeah? So I'm using the term variables for what we called features before. On every individual, you measure something, it varies across individuals, hence variables. So in the line plot, the variables are all both numerical as for the scatter diagram. Sometimes, however, variables are not numerical. Often, they can be locations on a map, they can be bits of music, and so on. For us, we are going to be dealing with a lot of categories. So last time we talked about, classifying the problems of classifying people into categories male, female, right? Those are categories. Maybe there's a finer division there. But categories are going to be quite important. And sometimes we want to visualize categorical data. So I will start with the simplest visualization with a totally made-up, straightforward table. How about... Okay, so what pets shall we have? No, why don't I do pet and make array. I was going to... Okay, what should we put in the array? Hamster? Okay, I just want to spend not the entire lecture getting this table done, so how about just 3 of these and and how many of each shall we have? How about 25 hamsters, 18 cats, and 7 dogs? Why not? Just for something to have. And so when we take a look at what we got here, okay. So we've got some community that has these weird set of pets, and I want to get some visualization of these numbers. Now with 3 numbers, this is pretty easy. You can just look at the numbers. The standard diagram is called a bar chart, just graph with bars. We will draw our bars horizontally because it's easier to label the bars that way. It's just you don't have to do vertical labeling. And so the method is called bar H. And it does this. So pets dot bar horizontal. You have to first specify the categories. So that's in pet. And you specify where the counts are. That's in number. And you get that. Right? Easy enough to follow. Life is easier with this one. Often you just have, if you just have 2 columns, as we do here, then you can simply say, the categories are in pet, and you figure out what the numbers are. So you're just going to assume that whatever the other column is, those are the counts. And so if you run that again, you get exactly the same thing. Okay. So that saves a little grief. Okay, so now what the bars are proportional to the counts. Right now, they are exactly equal to the counts. However, what we're going to see quickly is when we want to compare bar graphs and the total counts are different, you're going to want to convert to proportions first. So that's why I say they're proportional to the counts. A few things to note. Due to the fact that this, here, for the first time, you have an axis that's not numerical, those animals don't have some kind of universal order relative to each other. So in fact, you could what have I done? You could do that. That has exactly the same information. Right? Now, with a numerical axis, you can't permute. You can't put 5 in some different place relative to 7. But with qualitative data, you can. Also, please note that it is entirely up to the person who draws the picture how wide each bar is and how much space to put between the bars, because this is not a numerical axis. Now, we're letting Python do it for us, but if you draw a bar graph by hand, all you have to do is ensure that your bars are the same width and that the spaces are the same. Otherwise, you get into difficult visualization issues. All okay? All right. So, yes? Can I explain why I don't need number in bar H? It's actually better to include the number. It's a labor-saving device that Python gives you. If you have a table that just has 2 columns, it's going to assume that the other one is the counts. Now, on Monday, we'll do tables with multiple columns where you want to draw multiple graphs at once, right? And for that, this will be handy so that you don't have to name all of them. All right. So what I'd like to do now is I would like to use this. We're good for time today. Okay. And somewhere I have a line which says what the name of the table is. Maybe it's at the bottom. Right here. Okay. Okay. So this table contains what an IMDb website says is the top grossing movies of all time. And here the question that was raised a while ago is, have you adjusted the dollars? Becomes very, very important. Right? Because after all, what a dollar buys now is not what a dollar bought in 1930. And so the absolute amounts just look huge now compared to what they were in the 1930s. And what's happened is that the table has been done not adjusting. So the gross has not been adjusted. We have provided an additional column of adjusted figures, which I think is the same adjustment that they did in another table. So you have both, but I would just like to point out that the word top here is being used relative to the unadjusted numbers. Okay? So we're just going to stick with that today. And so, Star Wars The Force Awakens wins Avatar. Avatar. And what I'd like to do, remember 2009 had a bunch of movies? Had a lot of money and not a lot of movies released. So top dot where year are equal to 2000. Actually, is that numerical? I think it's numerical. That was what was going on in 2009. Right? People went to the movies. Good stuff. Okay. So what I would like to do now is I would like to look at this and explore some of these data. You have the data, so you can look through and see where your favorite movie, if it appears at all or not. It was a revelation to me to look at these, which are, the Titanic was this lush, romantic, movie scory thing. And everything else is very action-oriented. People like to go and see that kind of stuff. You should go down. E.T. appears in this list. I was happy to see that. So they are the top 200. What I'm going to do is just look at which studios produce these movies, right? Because Hollywood studios make decisions about which movies are going to be produced and released, and it's important to know where the money goes. Okay? So now I look at the studios. This is a categorical variable. Each movie falls into one of these categories, but we don't already have the counts. You see? So if I want to draw a bar graph, I want to know, among these 200 movies, how many of them came from Buena Vista, how many of them came from Warner Brothers, and so on. I need to do that. It hasn't been done already for me. There is a method called group that does exactly that. So what we're going to do is, let me give myself a cell here. We are going to take this movie, this table is called top. I will ask for the rows to be grouped according to the values in the variable studio. Okay. What I am hoping for in the end is one column with all the distinct studios, and then the other column with the counts. How many of the movies are in each? And you get exactly that. One movie came from that studio, which I don't know what that is. A lot of movies came from Buena Vista. That's a Disney subsidiary. It does the Star Wars movies and so on. Then there's Fox, there's Warner Brothers, and so on. A whole lot of them. And so what does group do? You give group a categorical variable as its column, and it will simply count how many rows are in each category and return to you a table. I think this is the first time where we are returning a table of new rows. It's not just rows from the old table. Right? This is a new calculation, and it has, you have a table. Now you can use this table. I don't need this one anymore. How about I just get rid of that? We can use this table, so top.group studio, and draw now a bar graph by studio. And if I do that, I get this picture. So now I can scroll down and see which ones are large. So Warner Brothers, Harry Potter, Batman, all of those movies, and so on. Now I look at this, and notice that group has sorted these by alphabetical order. So it's a categorical, it's a string, so it's just been sorted from low to high. For us, it would be nicer if you could see which one had the most and which one had the next most and so on. So why don't we sort by what? By count would be a good thing to do. So if we take this lowercase or uppercase? Lowercase, I believe. Yeah. So, by the way, this label was generated by group, by the method. It will always be that label. Lowercase count, you can use relabeled to give it any other name that you want. Sort count, how about descending equals true? And this makes sense to do because I have a categorical variable. There is no ordering to those names of the studios. I can do whatever I want. And so this is a natural thing to want to do. How am I doing here? And so this is an easier picture to see. Okay? So you can mess around with the axis on the categorical variable to get the picture in a form that is easy for you to interpret. You don't have that freedom with numerical variables. Numerical variables, the values are just in whatever order they are. And so numerical variables, you have to be a little more careful, and I'll be talking about that on Monday. How much time do I have? Okay, I have 4 minutes. I have 4 minutes to show you who you are. We've just developed some methods. I have been using them every single day to figure out who's in my class, who's in what section, etc. So I want to show you a little bit of that. Okay? And so what I'm going to do is I'm simply going to read in the roster from 2 a.m. today. I work late. And obviously rosters have names, SID numbers, email addresses. I've got rid of all that. I've just kept some information that does not identify people very easily. So D8 is my table, and that's who you are. So this is whether you're in the class or waitlisted. This is your section, this majors, and how many terms in attendance. And there are 511 rows admitted. So as of 2 a.m., there were 521 people on the enrolled plus waitlisted. That's who you are. And if you look at terms in attendance, freshmen are freaking out, going, oh my goodness, they're all seniors. But why don't we take a look, shall we? Yeah, so we have methods now. So we are going to take a look, and we are going to look at how many people are enrolled or waitlisted. Right. How do I find that? Which column? Roll. Right. What do I use? Group. Right? Just use group. Because there are two categories, student and waitlist student. And so if I do group by roll, that's who I got. 489 enrolled, 32 on the waitlist. The class limit is 500, and the reason for people being on the waitlist is there are lab conflicts. They're waitlisted for labs. They can't get into labs. We are working on that. Okay, so there's that. I would like to take a look at what is this variable called? What makes it look like everybody's a senior? Terms in attendance. Okay. Terms in attendance, we're going to group, yep, and I'm just going to draw the bar graph. So we're going to do that, and then we're going to do, and I have to tell it what the categories are, and the categories are these numbers right here. How many terms you've been in attendance, and therefore, do you actually want to know what? Before I do that, let me just look at the table so that people are clear what's going on. There's plenty of freshmen. But lots of people of different... Yeah, so this is... So shall we now take a look at a bar graph? The nice thing is that I will go back to my cell and I will simply add... Okay, look at that. Long, short, long, short, long, short. Why? It's the fall. You've got people in their first semester, you've got people in their third semester, you've got people in their fifth semester. Very few are in their second semester in the fall and enrolled in Data 8. Right? So we've got quite a spread. Look at 10, please. I had to do a coding. We have 11 graduate students in this class. I had to code them. I just called them 10. So I don't know how many years they've been around, but I just called them all 10. I want to show you something else. Who you are. By majors. Note, majors, I think, is plural in the table. It's plural because people have more than one major, some of them. Okay? All right, let's take a look. And I'm just going to look at everybody. Okay, so this is who you are. All the majors are here, all the counts are here. And the majors, they're in alphabetical order. That's who you are. Lots of double majors. There are a few crazy triple majors. That's who you are. That's who you are. All right, I'll see you Monday.